Section 4.4, exponential and logarithmic equations. Since logs and exponents are inverse functions, you can use them to cancel each other out when you're solving an equation. So the first examples we're going to look at, where they are an exponential equation, you'll first isolate the exponent, then take the log of each side to cancel out the bases, and you're just left with the exponent, and then you can solve. Or if it's a logarithmic equation, you will first isolate the log, then make each side be a power of whatever the base of that log was, and solve. We'll see that a little bit later in the notes. So first, 2 to the x equals 7. To cancel the 2, to bring the x down basically, we need to log both sides. Log base 2 and log base 2. So we have log base 2 of 2 to the x equals log base 2 of 7. So the log base 2 of 2 cancels, we're just left with x equals log base 2 of 7. And then to figure out what that approximately equals, we would do log of 7 over log of 2, or you could do log base if you want to go into the menu. I'd rather not go into the menu, so I'll just do log of 7 over log of 2 using the change of base formula, and you get 2.807. For our second example, same thing, but now we have the base is 3, so we're going to do log base 3 of both sides. So log base 3 of 3 to the x plus 2 equals log base 3 of 7. Log base 3 and the base of 3 cancel out, so we're left with x plus 2 equals log base 3 of 7. And then to solve it, you would just subtract 2. So equals log base 3 of 7 minus 2. So if we did log base 3 of 7, that's log of 7 over log of 3. I'm doing natural log. That's 1.77. Then subtract 2, we get negative 0.2287. Alright, a couple more examples here. Now first you need to remember that you need to isolate the exponent. So this 8 needs to be moved first. So since it's 8 times, we need to actually divide by 8 on both sides. That will reduce to 5 over 2. And then since it's e, we need to do log base e, which is natural log, so natural log both sides. So that cancels the e. Oops. Natural log and e cancel, so we get 2x equals natural log of 5 over 2. And then whatever we get there, we'll divide by 2. So natural log 5 over 2. Get that decimal, divide by 2. 0.458. So x equals 0.458. Over on this example, it's already isolated as just an e, so we need natural log both sides. Natural log cancels e. 3 minus 2x equals natural log of 4. So then we'll subtract 3. And then divide everything by a negative 2. So start natural log of 4, get that answer, subtract 3, and finally divide by a negative 2. So our final answer, 0.807. Now this example is a little bit more difficult. You actually need to first factor before you can do anything. You might not notice right away, but this is factoring like you remember from x squared plus 3x plus 2, something like that. It's the same idea here, because e to the x times e to the x will be e to the 2x. So this will factor into this form. So we're looking for what multiplies to be a negative 6, but adds to be a negative 1 in the middle. So that's going to be negative 3 times positive 2. And we add them together, you get negative 1. So now, just like in algebra 1 or 2, once you get this set up, you set them both equal to 0. So we have e to the x minus 3 equals 0. Or you could have e to the x plus 2 equals 0. Isolate the e to the x. E to the x equals 3. Or e to the x equals negative 2. And then to cancel e, you do natural log on both sides of both equations. Natural log cancels e. So we have x equals natural log of 3 and x equals natural log of negative 2. You could get your decimal approximation, natural log of 3. So x equals 1.099. And on the other side, natural log of negative 2. You'll notice that you get an error, because if you remember back to our domain of logs, domain has to be greater than 0. So we can't plug a negative 2 into a log. So if you're ever not sure why you're getting an error, click the Go To button, and it'll tell you, it moves the cursor to the spot, and since it's right there by the negative 2, that's your issue. There's another example where you need to factor. So in this case, though, we are looking for a common factor. Oh, real quick before we move on, this is our only answer since this one doesn't work out. So we're looking for our common factor. They both have this has x squared, this has x to the third, so we can take out an x squared. They also both have e to the x. If we take out both of those, we'll still have a 3. And that would be it for the first part. Plus, there'll still be an x left over. Now, there are 3 parts to this. There's x squared, e to the x, and 3 plus x. Set each part equal to 0 separately. It's the part where I call t it up. X squared equals 0 means x equals 0. E to the x equals 0, which anything to the we're not going to be able to get a 0 there, right? And we can also have 3 plus x equals 0. So x would equal negative 3. So To solve this, we would natural log both sides. Cancels out. Natural log of 0, though, we can't do. So you get no solution from that part. But you do get x equals 0 and x equals -3. Before we move on, just want to let you know that exponential functions are a beaver's favorite type of function because you have to log both sides. Two of you are probably laughing right now. So now let's look at the other types of functions. Log base 2 of x plus 2. So to get rid of log base 2, make both sides become a power of that base. So the 2 will cancel out log base 2. X plus 2 equals 2 to the 5th. 2 to the 5th is 32. Subtract 2, you get x equals 30. To get rid of natural log of x, to get rid of the natural log, make it be a power of e. E cancels natural log, we get x equals e to the 8th. If you want the decimal, you could type it in. E to the 8th power is 2980.96. And again, we have log base 2, so make both sides become powers of 2. 25 minus x equals 2 to the 3rd, which is 8. Subtract 25 from both sides. Negative x equals -17, so x equals +17. So again, remember, first step is make sure that the log is by itself. So we can first subtract 4. And to get rid of 3, you can divide. So we have log of 2x equals 4. Since they don't write the base, that means it's base 10, so make both sides be a power of 10. 2x equals 10 to the 4th. And finish it off by dividing by 2. That'll be 5,000. X equals 5,000. And the last one we're going to look at, we have 2 logs. We know that when you have logs with the same base 10 in this instance, you can, if it's addition, you combine them by multiplying. So this is log x plus 2 times x minus 1 equals 1. 10 to the power on both sides. So we have x plus 2 times x minus 1 equals 10 to the 1st, which is 10. FOIL it out, you get x squared plus x minus 2 equals 10. You have to finish it off by moving the 10 over, so subtract it, you get -12. You can solve by factoring. X plus 4, x minus 3. So our two answers, x equals -4 and x equals +3.